In this calculation, we included them. What do you mean by that, Charmin? Yeah, because the 32 people are part of this 129. So we have already counted them under 129. So therefore, we need to subtract those 32 people. So because these 32 people already part of this, so you have to remove this. This is what I cleared this and show you the formula. Okay, so if you see here, the formula is probability of A or B. Okay, so probability of A or B. So probability of A or B is probability of A plus probability of B minus probability of A and B. Okay, so we need to subtract this probability of A and B from the calculation. All right. Okay, so let us move on to the next part of that. Okay, so this is basically the answer for this. So probability of creative display, so 82 over 276. So probability of creative display are informational resources. Okay, so this is one independent event. So you just add up the total over the sample space. Okay, that gives you 0.4167. So probability of business website or online sales, so that will be 0.5145. We have seen this. Okay. The next topic is on discrete probability distributions. Okay, so the basic probability, the questions will be, so based on the contingency table, okay, the data will be given in terms of a contingency table, and you need to calculate the simple probabilities. Okay, the next one is the probability distributions for discrete data. Okay, so discrete data means, the whole numbers. So for under this, the important formulas which we can review is how to calculate the mean or expected value. Okay, so the mean or expected value for discrete variable is, so you have to, from the table data, so take every point, multiply it with its probability. Okay, then the formula for variance is given here, and the square root of this variance is your standard deviation. Okay, so under discrete probability distribution, so we have two types of models. One is the binomial distribution, so the other one is the Poisson distribution. Okay, so for binomial distribution, we have the formula. So the formula is given here. Okay, for binomial distribution, the mean can be simply n into pi. Okay, so n is the sample size, so pi is the probability given. So the standard deviation is simply n pi into 1 minus pi. Okay, so Poisson distribution, the formula is exponential power minus lambda to the power of x over x factorial. So how to do the combinations, NCX, the formula is n factorial over x factorial, then multiplied by n minus x factorials. So we have seen all these formulas. So under discrete probability distributions, so these are the important formulas. So binomial distribution and Poisson's distribution. Then how to calculate the expected value of a discrete variable. All right. So with this background, we'll move on to okay. So read the question, try to understand what is the data given, and try to answer the questions. So the table contains the probability distribution of the number of traffic accidents daily in a town. So here, the number of no accidents, 0 accidents. So the probability is 0.1. 1 accident, the probability is 0.2. So 2 accidents, the probability is 0.45. So 3 accidents, the probability is 0.15. So 4 accidents, the probability is 0.05. So 5 accidents, the probability is 0.05. So the total probability will be 1.0. All right, so this is the discrete probability distribution. So number of accidents, X variable, what is the probability of that variable? Okay, so probability of 0 is 0.1. So probability of 1 accident is 0.2. So probability of 2 accidents is 0.45. Okay, so the total probability you will get 1. Okay, so for this data, so the first part of the question asks you, compute the mean number of accidents per day. So you may just note down the data. So please note down the data. All right. So I just prepared the data X, probability of X. So next you need to come out with another column. So we need to multiply X with probability of X. So when you multiply 0 with 0.10, so you get 0.00. So 1 with 0.20, so you will get 0.20. Then 2 when you multiply with 0.45, sorry. Okay, so 2 multiplied by 0.45, how much you get? Yep, 0.90. Then 3 multiplied by 0.15, so you get 0.45. Then 4 multiplied by 0.05, so you get 0.20. Then 5 multiplied by 0.05. Okay. So the mean is nothing but the sum I is equal to 0 to 5. Okay. So x into probability of x. So you need to just add up all the column. Okay. Add up all these numbers. How much you get? Sum of x into probability x. Yeah, that's correct, Dennis. Thank you. So 2.00. So next what we need to do is we need to prepare another column x minus. So the mean is now 2.0, right? So the mean of x bar whole square. So from every point we need to subtract the mean. Okay, so this is 0 minus 2. 0 for this. So 0.00 minus 2.00 whole square. How much you get? Yep. So you get 4. So the next one you need to get 0.20 minus 2.00. X is 1. So 1 minus 2. 1 minus 2 is 1 square. So you'll get 1. So x is 1, mu x is 2. Mean is 2. So 1 minus 2 is 1. 1 square is 1. So then 2 minus 2, 0. 0 square is 0. Then 3 minus 2. Okay. So 3 minus 2, 1. 1 square is 1. Then 4 minus 2 is 2. 2 square is 4. Then 5 minus 2 is 3. So 3 square is 9. Okay. So then you need to prepare one more column. Okay. So this column is x minus mu x bar whole square. So that means whatever we have done under this column multiplied by the probability of x. Multiplied by the probability of x. So I'll wait for your answer. Please let me know what is the first answer. X minus mu x is 4. So what is the probability of this? 0.1. So 4 into 0.1. Oh, my screen is smaller. Can you see bigger now? Okay. So 4 into 0.1 is 0.4. Correct. Next one. So 1 into 0.2. 0.2. That's correct. The next one. 0 into everything will be 0. Correct. So I put additional 0. Okay. Then 1 into 0.15. So that will be 0.15. That's correct, May. Then 0.2 into 4 into 0.05. So that is 0.20. The last one. Yes, 9 into 0.05 is 0.04. I'm sorry, 0.45. So 0.45. So then you add up the whole thing. So sum of x minus mu x square into probability of x. So if you add up, how much you'll get? So 0.4, 0.6, 0.75, 0.95, then 1.40. That's correct now. So you will get total 1.40. So then we can write standard deviation. So the formula for standard deviation so we can say the standard deviation is 1.40. All right. Okay. So we have answered the first question, compute the mean number of accidents per day. So the mean number of accidents we got is 2.0. Then we answered the standard deviation. So compute the standard deviation. So standard deviation, we got 1.40. Then the mean, we got 2.00. So there will be 2 accidents average per day. And the variation is 1.40. Then part C. So the part C, the question is asking us to calculate what is the probability that there will be at least 2 accidents on a given day. So what will be the probability of at least 2 accidents on a given day? So that means, how do we write this probability of X greater than or equal to? So what is the probability of X greater than or equal to 2? Okay. So how do we do this? Probability of X greater than or equal to 2. Anyone, any idea? Yes, that's correct. So probability of greater than 2 means, so you need to just add up all this. Okay, 0.45 plus 0.15 plus 0.05 plus 0.05. So you will get the total is 0.70. Yes, you need to square root. Let me see what I have written. Yeah. Now, 0.2. I think 0.6, 0.75, 0.95, 1.4. Yep. So you have to square root this, then how much you get? 1.182, 183. So the standard deviation, please make a correction. So you have to take the, thank you, Shamin, I think you pointed out this. So we have to take the square root of 1.40. So that gives you 1.183. So this is 1.183, mean is 2. Then we have seen probability of X greater than 2 is greater than or equal to 2 is 0.720. Better to show formula. Check, I think you must show the formula. That will be, because all the formulas will be there. I think guys, don't send personal messages, so you can message everyone. Online. Can you see William now? All right. Okay, so the third question can be something similar. All right, so I can show you the working for this. So the working is, okay, so this is the working. If you want to take, you can take a screenshot of this. All right, so after the discrete probability distributions, then we can go to normal distributions. Okay, so in the normal distribution, the basic formula for normal distribution is mathematically we can write like this, but this formula will not use at all. So for any calculation, this formula is not required. So what is required is the transformation of the data given into the G statistics. So the G statistics is X minus mu over sigma. So can someone tell me what is mu? So mu is, if you just say mean, that's not sufficient. It is population mean. Sigma. So what is sigma? Yes, population standard deviation. Okay, so this is the formula which we'll be using most of the time. Okay, so the G statistic is X minus mu over sigma. Now from this formula, we can also write X as mu plus G into sigma. Okay, so if you know mu and sigma, then we can calculate Z. Okay, if you know the G, then we can calculate, we can find out X. Okay, so one of this we'll be able to find out, because one equation, one variable we can find out. All right, I clear this, then we move on to, okay, now look at this question. Given the normal distribution with mu, the population mean as 50 and the population standard deviation as 4. Okay, so you are asked to find what is the probability that X is greater than 43. So what is the probability of X greater than 43? So how can you calculate this? So first we need to find the G statistic for this. So X minus mu over sigma. So when X is 43, okay, so what is the G value? So 43 minus 50 over 4. So this is minus 7 over 4. Yeah. I think, Jackie, you need to take note of the sign. It is negative 1.75. So the negative sign is important. So that means probability of X greater than 43 implies, so this implies, so probability of G, okay, greater than minus 1.75. Now, can you look into the tables and Z distribution tables and let me know what is the value for negative 1.75? So negative 1.75 greater than. So you can imagine the curve like this. Okay, so negative 1.75 is something like this. I think, Dennis, your answer is correct. So you are looking the entire area. So here the mean is 0. So the area well of this is, if you look into, yeah, 0.9599. Okay, so probability of Z greater than negative 1.75. So if you look into the probability tables, I think some of you pointed out correctly. So this is 0.9599. All right, and now can you do the calculation for the second one? Probability of X less than 42. Oh, Dennis already answered this question. So you need to find out what is the Z value. So Z is 42 minus 48, I'm sorry, 42 minus 50 over 4. So this is minus 8 over 4, that gives you negative 2.00. Okay, so what is the probability of Z less than minus 2.000? So in the exams, we expect you to write step by step all the calculations like this. So don't just give the final answers. So you need to write all the steps to get full marks. So minus 2.20 is somewhere here. So you can say this is minus 2.0. So you are only looking this area. So this area is 0.0228. So part B, you can say that it is 0.0288. Now, can someone answer the next part of the question, part C? So 5% of the values are less than what value of X? So 5% of the values means what is the probability of Z? So it is probability of X less than A. So this 0.9599, you have to refer for probability of Z less than negative 1.75. Okay, so probability of Z greater than minus 1.75 standard deviation. So minus 1.75 is somewhere here. So this is 0. So therefore you are looking at the entire curve. Okay. So I think someone wrote as 1 minus 0.0401. So Dennis has written this 1.0.0401. So if you do this subtraction, so you will get 0.9599. Because the entire area of the curve is 1. So from that curve, now look what is the value from the probability tables for minus 1.75. Okay, so just subtract that. So from 1, so look for negative 1.75. So the value will be 0.0401. So the total area under the curve is 1. So the area of the curve below 1.75 negative is 0.0401. So if you do this, then you will get 0.95999. All right. So the next part is the probability of X less than value A. Okay, you need to find out X value. Okay, so the probability given is 0.05. Okay, 5% means 0.05. So the probability is 0.05. So what is the value for the G value for 0.05? So what is the Z value for 0.05? No, it is not negative 1.96. So that is for, you can refer the same tables. So look for 0.05. Oh no. Now the Z value, I think you will get negative 1.645. So you can refer probability when the Z value is 0.05. So what is the, when the probability is 0.05, what is the Z value? So the Z value will be negative 1.645. So this one you can write A minus 50 because the mean is given as 50. So we can write A minus 50 over 4. So you can write A minus 50 over 4 is negative 1.645. So then you need to calculate what is the value of A. So you can write A as 50 minus 4 into 1.645. So if you do this calculation, so you get the value will be 43.42. So for 5% probability, you need to check the G value. So the Z value will be negative 1.645. So when the probability is 0.05, then the Z corresponds to negative 1.645. All right, guys, I think the time is now 8:30. No, same Z table, Shamin. So you look for the 0.05 and find out what is the corresponding Z value. So from Z distribution tables, so don't look for the Z value. So find out where you can find the 0.05. Then read the corresponding Z value. Never mind, I'll show you later. Okay, we'll have a break now. Then we'll meet at 8:45. I can show you from the probability tables. Okay, the Z distribution tables. All right, guys. No worries, no worries. Okay, so let's have a break and let's meet at 8:45. I see you then at 8:45. Hi guys, hope you're back. Shall we start? All right. I think Shamin was asking about this. So you may, this is the statistics book I'm referring. Okay, so this the normalized cumulative standard normal distribution table. So you can see 0.050 here, 0.5. So 0.0495 here. So here this is 1.6 negative. This is 1.04. Okay. So you can see here 0.04 and 0.05. So in between you can find the value 0.05. All right. So you will be able to read the value for probability of 0.05 as minus 1.645. Okay. Minus 1.6 is here, 0.04 here. So minus 1.64, and in between. So we can say it is negative 1.645. Is that clear? All right. This is your business statistics textbook, old version, and you can find the tables in the online. Also, you can download from any website these tables. All right. I move on from here. Always for 5%, the value is standard. So you can consider it as negative 1.645. Okay, so we answered the last question. Next, yeah, so if you want, you can just take the screenshot of this. All right, I move on to the next topic. So the next topic is about the sampling distributions of the mean and proportion. Okay, so the mean and proportion. So here we are talking about the population. Okay, so when we are talking about the population mean, okay, the formula for population mean, we can see the symbol is mu here. Then this is the formula for the population standard deviation. So we use sigma and the sample size capital N. Now, when we are dealing with samples, okay, so for the sample mean and population mean will be the same, but there will be error when you're calculating the standard deviation for the sampler. For the sample, the standard deviation will be sigma over square root of n. So sigma is the population mean, So n is the sample size. Okay, so please take note, this formula is important. Okay, this is part of your central limit theorem. Okay, so which is also known as the standard error of the mean. So when we are dealing with the samples not from populations, then the standard deviation for the sampling distribution will be sigma over square root of n. Small n is the sample size. So the G statistic for the sampling distributions will be so the formula is Z is x minus mu over, okay, sigma over square root of n. So we are putting the standard deviation of the sample mean. Okay, so the G static for the sampling distributions will be x minus mu over, okay, x bar is the sample mean. Okay, mu is the population mean over sigma is the population standard deviation, then over square root of sample size. So the G statistic formula will change for sampling distributions. So when we are dealing with sampling distributions. So similarly, you can find out the sample mean. X bar is the sample mean. Okay, so from this formula. So there is another characteristic other than the mean is the proportion. So sample proportion. So sample proportion we can define as x over n. Okay, then when we are dealing with proportion instead of mean, okay, so then the standard error for the proportion will be, so sigma p is equal to pi into 1 minus p over n, the whole thing under square root. So this is the standard error for the proportion. So proportion is another variable. In many times we cannot define mean for a data set. So but we can define proportion. So this is, say, when you try 50 times, let us say you succeed 25 times. So then your proportion will be, so 25 over 50. So out of 50 chances you succeed 25 times. So your proportion of success is 25 over 50 or 1 over 2 or 0.5. So we cannot define in such cases mean. So mean has no meaning in many cases. So there we can define proportion. So when we are defining proportion, then the standard error for the proportion will be pi into 1 minus pi over n. So similarly, when you're calculating the G static, okay, so the formula for G static will be, so p minus pi over, so the whole thing, standard error. All right, so when you're dealing with sampling distribution, so you need to know the standard error for the mean, okay, then the concept of the proportion, then the standard error for the proportion, and how we define the G static for proportions. Okay, we need to apply the central limit theorem in when we are dealing with sampling distributions. Okay, when we are dealing with samples not from population data. Okay, so then we need to apply the central limit theorem. So the central limit theorem basically tells that the standard deviation of the sample mean is sigma over, sigma is the population standard deviation, square root of n, n is the sample size. So this is the central limit theorem or the standard error. All right, so based on this, now we move on to the next topic is the confidence interval estimation. So so confidence interval estimation, there are two categories. One, when we know sigma, when we know population standard deviation. So when we know population standard deviation, then we apply the G static. Okay, so the G static we can apply. So we can find out the sample mean values between two limits. So depending on the Z value. So when sigma is unknown, when sigma is unknown, then we need to bring the t distribution or student t distribution. Okay, so for student t distribution, you need to know the sample size. So then we need to write the degree of freedom. So degree of freedom will be n minus 1. So we can write. Okay, so we will be using the t distribution tables. Okay, so this is degree of freedom. So t distribution tables we looked into during the last session. Okay, so this is the formula we'll be using for confidence interval estimation when the population standard deviation is unknown. So please do remember, when you don't have the sigma value in the description, then you are using the t distribution tables. When sigma is known, we can use the G static. Okay, the Z value, Z tables. When sigma is unknown, then we have to use the t distribution tables. Okay, when instead of mean, we can deal with proportion. Okay, so when you are dealing with proportion, then the confidence intervals can be estimated, okay, from this formula. Next, the sample size can be determined. What should be the required sample size when we know the sampling error E is given? Okay, the error is given, then what could be the sample size? So this is for mean. Okay, this formula is for mean, and this formula is for the proportion. So there will be one question which will be asked to calculate the sample size, okay, based on one of these formulas. Okay, so this is about confidence interval estimation for the. All right, so I clear this, then move on to the next question. All right, so can you read this question, understand, and try to work on this? So if you want to be 99% confident, so this is your confidence interval, estimating the population mean to within a sampling error. So the error E is plus or minus 20. And the standard deviation is assumed to be 100. So sigma is given as 100. Okay, and you are looking at 99% confidence interval. Okay, so your confidence interval is 99%. Okay, so the E value is given as plus or minus 20. So we have to use the sample size formula. So the formula for the sample size is so in this case, the standard deviation is given, and we are dealing with population mean. Okay, so we can use the G static and population standard deviation over the sampling error, square of the sampling error. So here we are looking at alpha over 2, 99%. So here this is 0.05. So you need to look for 99% value. So what is the G value for 99% confidence interval. So you may refer the tables for 99% confidence interval. You can refer the Z distribution tables to find out the 99% value. I'm just referring the tables again. So for 99%, so this is somewhere here, 99%, but you need to look for 99 point. Okay, 0.995. So you can see. Okay, so the value is between 2.67 and 8. So this is 0.995. So this is a two-tail. So 99% means we are taking half of the value. So 0.995. So 0.995 will correspond between 2.5 and 8. So you can say the Z value is 2. Okay. So the formula is the sample size n is equal to, so you can write over E square. So the Z value for 99% confidence interval is 2.58. This is again from the tables. Then sigma is given 100. So 100 square okay, Sharmin, I'll tell you. Let me just write down this. Over 20 square. So if you do this calculation, I think you will get about 166.4. So the sample size, we write it to the next higher number. So n should be 167. So when Z is 99%, okay, so when you're looking at Z of alpha over 2, so here the remaining one is 0.01, right? 1% corresponds to 0.01. So 0.01 over 2. So that will give you, I'm sorry, it is not 0.05. So it will be 0.005. So 99% is given for us. Okay, it's a given confidence interval. So for sample size determination, so we'll be using alpha over 2. So alpha is the standard error. So the error in this case is 0.01. So alpha over 2 is 0.01 over 2. So that gives you 0.005. Is that clear, Sharpen? All right. So there will be one question where you will be calculating the sample size. And for this type of question, there will be only 5 marks. All right, I clear this, then we'll move on to the next question. So the next topic after confidence interval estimations is the last topic, which is hypothesis testing. Okay, so hypothesis testing, again, we do basically 2 different ways. When we know the population standard deviation, when sigma is known, okay, so then we use the G-stat. Okay, so again, if we are not sure of the, if we are dealing with sampling distribution, sample mean, okay, so then we have to use the central limit theorem. So standard error, instead of sigma, we are using sigma over square root of n. So when sigma is unknown, when the population standard deviation is unknown, then we'll find the T-stat. Okay, this critical value will be T-stat. So in this case, x bar minus mu over s over square root of n. So can someone tell me what is s? Anyone s? S is sample standard deviation, correct? What is x bar? X bar is sample mean. Okay, so it is not population mean, it is sample mean. So there are 2 scenarios now. When sigma is known, for when we are dealing with mean, okay, we can use the G-stat to calculate the hypothesis testing. Okay, if sigma is unknown, so this is definitely there will be one question where you will not have sigma value. So you will have only the sample standard deviation. So then you will be using the student t distribution. So this is when the variable is not mean, but it is proportion. Then we use the G-stat values. Okay, so this is the background of hypothesis testing. After this, then we can do the, okay. So the 20 marks questions will be mostly based on hypothesis testing and based on the binomial and Poisson distributions, the discrete distributions. Okay, let us look read at this question. This is something for 20 marks type questions. Okay, the director of a manufacturing clothing factory needs to determine whether a new machine is producing a particular type of cloth according to specifications. So which indicate that the cloth should have mean breaking strength of at least, okay, 70 pounds. So this is the first data which is given, and a standard deviation of 3.5 pounds. Okay, so the mean is given as 70 pounds and the standard deviation is 3.5 pounds. Now the director is concerned that if the mean breaking strength is actually less than 70 pounds, if it is less than 70 pounds, the company will face too many lawsuits. So for this, a sample of 49 pieces of cloths. Okay, so the sample size is 49 here. Reveals a sample mean of 69.1 pounds. So X bar is sample mean. So sample mean is 69.1. Okay. So the sample size N is equal to 49. So what is the population mean? Mean breaking strength sigma is equal to, or mu is equal to 70. Population mean. So population standard deviation is 3.5. Okay, so we get the data for the population mean and population standard deviation. And also we have the sample mean and sample size. Okay, sample mean and sample size. Now in this case, you're asked to write down the null and alternate hypothesis. So here, how do you write the mean breaking strength, the null and alternate hypothesis? Now you can see that now the director is concerned that if the mean breaking strength is actually less than 70 pounds, okay? So from this, how can you write the null and alternate hypothesis? Okay, guys, so we can write the null and alternate hypothesis something like this. Okay, we can say the null hypothesis is, so he believes that it is greater than or equal to 70 pounds. So what does this mean? So this means that the mean breaking strength is the mean breaking strength of the cloth is at least 70 pounds. So this is the null hypothesis we can write. So what is the alternate hypothesis? Alternate hypothesis is you want to test whether this is okay greater than or this is null hypothesis. So alternate hypothesis is less than 70 pounds. So this means that the mean breaking strength is less than of the cloth is less than 70 pounds. Okay, so we can write null and alternate hypothesis like this. Next, let us look at part B. So at the 0.05 level of significance, so using the critical value approach of hypothesis testing, is there evidence that the mean breaking strength is less than 70 pounds? So here we need to find whether the mean breaking strength is less than 70 pounds. So we have to calculate the test static for this. Okay, so for part B, we have to find the decision test statistic. So the test statistics, the Z value will be, so the sample mean minus population mean over the sample standard deviation square root of the sample size. Okay. Now, what is the sample mean value? Anyone, can you tell me what is the sample mean? From the description of the problems? That's correct, Jenny. Thank you. 69.1. What is the population mean? 70 over the standard deviation given for the population is 3.5 and the sample size is 49. So if you do this calculation, you will get the test statistic value. So can someone tell me how much is this? Negative 0.18. That's correct. I'm sorry, negative 1.80. So you calculate the test statistic value as minus 1.80. But we need to test this at 0.05 significance level. So what is the value for Z at 0.05 significance level? So at 0.05 or at 95% significance level, the Z value will be negative 1.64. So this is the critical Z value. Okay, so you can say Z critical, Z critical 1.645 at 0.05 significance level. Now, so the calculated value is, so the G calculated is negative 1.80. So the Z critical is negative 1.645. So this is for alpha is 0.05. So that is for 95% confidence. So now what is your decision? Anyone? The critical value is negative 1.645. The calculated value is negative 1.80. So what will be your decision? You want to reject null hypothesis or do not reject? Yeah, when you look probability tables again, okay, this value is standard. Okay, 1.645. I explained you earlier also for 95% confidence or at a significance level of 0.05. So from Z distribution tables, so you look for 0.05, then corresponding Z value will be 1.645. You need not worry about these values. So you only get, okay, alpha is 0.05 and alpha is 0.10 and alpha is 0.01. So these are the only three things you will be asked. Okay, three significant levels. Out of these three significant levels, okay, most of the time you will be either asked this. Okay, so for this it is negative 1.645. So similarly, you can find value for 0.10 and 0.01. Okay, so you can list, I think in one of the previous slides, I showed you these numbers. So for 95%, critical value is negative 1.645. Okay, from the Z distribution tables. Then it says acceptor. Now the decision, because the critical value, the test statistic is, okay, the calculated value is less than critical value. Okay, so therefore we reject null hypothesis. So the decision is reject null. Okay, since the calculated value is less than the critical value. Okay, so if you write this much, that's good enough. So in this case, the decision is to reject null hypothesis because the calculated value is 1.80 negative, whereas the critical value is 1.645 negative. So since the calculated value is less than the critical value, so we reject null hypothesis. Oh, no, we don't accept, Charmaine. We reject null hypothesis. All right. Okay, so then we move on to the part B. So the part B we have done. Next, part C. So part C is asking you at the 0.05 level of significance. So now you are asked to use the probability value. So p-value approach to hypothesis testing. So is there evidence that the mean breaking strength is less than 70 pounds? So now instead of the critical values, what we are going to do is we are going to use the probability approach. So what is the probability value given? Okay, so 0.05. So for part C, the value given is 0.05. Okay, so for part C, what we can do is so the decision rule is so if p-value is less than 0.05, okay, so reject null hypothesis. So this is the probability decision rule for probability. So what is the test statistic? We have calculated already. Test statistic is so x bar minus, I just write again, mu over square root of n. Okay. So what is the sample mean? So this one we just calculated 1.80 negative, right? So what is the p-value? So what is the p-value for negative 1.80? You can check your Z distribution tables. So you can find from the Z distribution tables, the p-value will be 0.0359. Okay, so you can check the probability value for negative 359. So you have to just look again. Okay, so this is 0, this is minus 1.80. So the probability will be here. So we can write since p-value is 0.0359 is less than alpha. So which is given as 0.05. Okay, so therefore reject null hypothesis. Yes, any doubt? Okay. Yeah, we always reject if it is less than alpha. That is the rule. That is the decision rule. All right. So that is the part C. Then part D is asking you for us to interpret the meaning of the p-value in this problem. So what is the meaning of the probability value? Then the last part of the question is compare your answer in both cases. So compare your conclusions in part B and part C. So what is the meaning of the p-value in this particular problem? So the meaning of p-value in this problem is that the probability of, we can write down one or two sentences only, obtaining a sample whose mean is so 69.1 pounds or less when the null hypothesis is true is 0.0359. So that means if you think the null hypothesis is true, then there is only probability of 0.0359% to get the mean strength as 69.1 pounds. So you are asking, is this you want, Kai? Okay. Then for part E, so both the conclusions are the same. So that means whether you use critical value or the probability value, so the conclusions are reject the null hypothesis. So we are rejecting the null hypothesis in both the cases. I go back to the slides. Okay, so this is one of the question for 20 marks. So you may have something related with hypothesis testing. You need to define null hypothesis, alternate hypothesis. Then you need to test the hypothesis using the critical value, the Z critical, then use the probability value, then comment on the results. All right. So I move on to the next question. I click OK. So the next one is the director of admissions at a university advises parents about the cost of textbooks. So during a semester. So a sample of 100 students enrolled in the university indicates a sample mean cost of $315.40 with a sample standard deviation of $43.20. Okay, so here you have the sample size 100 students, the sample mean given $315.40, the sample standard deviation given. Okay, so 100 students is the sample size n. So sample mean cost, so this is X bar. Okay, so this is sample standard deviation S. Okay, now for this data, using the 0.10 level of significance, so that means you will you put all the questions with the answers? Okay, no problem, Septianti. I'll put all these things, no worries. Okay, so you are looking at 90% confidence interval or at 0.10 level. Okay, so is there evidence that the population mean is above $300? Okay, so this is the first part of the question. So how do you write the null hypothesis and alternate hypothesis for this? For part A. So the null is anyone? Is there evidence that the population mean is above $300? So this is, you are going to say that it is no more than $300. So you can say the null is less than or equal to $300. So you can say that the mean is, so population mean is less than or equal to $300. I clear and write again. So you can say the null is population mean is less than or equal to 300. Okay, alternate hypothesis. So you can write alternate hypothesis as population mean is greater than $300. All right. So using the 0.10 level of significance, is there evidence that the population mean is above $300? So null hypothesis will believe it is less than or equal to $300. So the testing alternate hypothesis is greater than $300. So we need to test this hypothesis. So what type of test statistic we use? So what test statistic we can use? So in this case, we don't have the data dealing with the population mean or population standard deviation. So we'll be using the T statistic. So the T statistic is X bar minus mu over sample standard deviation over square root of the sample size. So what is the X bar value given? The sample mean. So sample mean is $315.40. Okay, the population mean is $300. Okay, so the sample's standard deviation given is $43.2. Okay, the sample size is 100. Okay, so we can do this calculation for T statistic like this: X bar minus mu over S over square root of N. All right, so once you do this calculation, so anyone, any answer for this? That's correct. So you will get about 3.56. I think if I go 4 digits, it's 3.5648. Okay. So the decision rule is okay. Now, what is the degree of freedom? So degree of freedom is n minus 1. So degree of freedom is 99. Okay. Now, for degree of freedom of 91, 99, and for a test statistic of 3.5648. So this is the calculated value. So you can refer for 99 degree of freedom. So what will be the T critical value? So the calculated value is 3.5648. Okay. So if T is greater than 1.2902, so this is the critical value, then reject null hypothesis. So we need to refer the T value for the degree of freedom of 99 and at a confidence level of 0.10. So you can get this value from the T distribution table for a degree of freedom of 99 and for alpha of 0.10. Now, what is the decision? So the calculated value is 3.5648. The critical value is from tables for the given degree of freedom of 99 and confidence level of 0.10. So this is 1.2902. So calculated value is above the critical value. So therefore, reject null hypothesis. So what does this mean? So this means, so there is enough evidence to conclude that so the average cost of the textbooks is more than $300. Okay, so you can write your answer and calculations like this. Yeah, I think Sharmin is asking, how do you get this? So you look for T distribution tables for a degree of freedom of 99. So you have to look for T tables. DF is degree of freedom 99. Alpha over 2 is 2 tail is 0.05. Okay, alpha is given 0.10. So you can look at the tables here. These are the T distribution tables. Okay, so this is the critical value of T. So I'm looking for 99 degree of freedom. Okay, so this is the alpha value is 0.10. So this is upper tail alpha is 0.10. So for 99 and 0.10, so the value is 1.2902. All right, so you can find this from the T distribution tables. All right, so we calculate what is the T value from the given data. Then we compare this with the degree of freedom and the given significance value. From the tables, we can read the value. Then we compare these two. Okay, so if the calculated value is above the critical value, we reject null hypothesis. And in this case, the calculated value is above the critical value. So therefore, we reject null hypothesis. So we reject null hypothesis. All right, so I'll move on to the next part of the question. All right, so I hope you can see, right, the slides. So the next one is, what is your answer in A? Okay, if the standard deviation is $75. So instead of 43.20, so if the standard deviation is $75, so what happens at the 0.01, 0.10 level of significance? So I'm sorry, and the level of significance is given as 0.05. Okay, so for part B, we are using the sample standard deviation as $75 and alpha is 0.05. All right, so we do the similar calculations for part B. Okay, so for part B, okay, so for part B, what we can write, the test statistic. Okay, the degree of freedom is again 99. There's no difference. Okay, then you have to, alpha is 0.05. So can someone tell me what is the value for T critical? Then calculated value, test statistic value. So the t value will be x bar minus mu over sample standard deviation over square root of n sample size. So x bar is sample mean is the same 315.4. Okay, the population mean is $300. Then sample standard deviation is now for this problem $75. Okay, the sample size is 100. So you can use this to calculate the test statistic. So for part B, we need to, okay, the standard deviation for the sample is given 75 and the alpha value is given as 0.05. Can someone tell me from the t distribution tables for a degree of freedom of 99, what is the critical value? Yes, Dennis is correct. So the value is 1.660. Okay, when you calculate how much you get? So from this calculation, I think you will get as 2.05. So what is the decision? Okay, so since the calculated value is 2.053 is above critical value of t is equal to 1.660. Okay, so reject null hypothesis. So in this case also we reject null hypothesis. So that means there is enough evidence to conclude that the average cost is more than $300. Okay, so reject means so the average cost is more than $300. So you can say there is enough evidence to say that the average cost is more than $300. All right, so this is part B. So the difference is the sample standard deviation is given 75 and the significance level is given as 0.05. Now let us move to the next question. So part C is, so what is your answer in A? If the sample mean is $305.11 and the sample standard deviation is 43.20. So for part C, the data is slightly different. So the mean is given as 305.11. Okay, and the sample mean. Okay, you need to know the sample mean. All right, so for part C, how do we calculate? So for part C, so test statistic, how can we calculate? So test statistic is x bar minus mu over same formula, sigma, I'm sorry, S sample, S over square root of n. So this is S. So sample mean for this one is given as $305.11. The population mean is $300. The sample standard deviation is given as 43.20. So the sample size is 100. Okay, so if you calculate this, okay, I think you will get 1.1829. All right, so for part C, the calculated T value is 1.1829. Then for a degree of freedom of 99, so critical value. So how do you get the critical value? So the critical T, so degree of freedom is 99, and alpha is given as okay, 0.10. So anyone can give me the value for T? That's correct. T value is 1.29. That's correct, Dennis. All right. So now what is your decision? So what is the decision? So the decision is do not reject for part C. So do not reject. So is that clear, guys? Yes, Sharmin, anything? How to get 1.29? For part B, I think somebody told me it is 1.660. So you have to use the same logic. So for degree of freedom of 99, okay, the given level of significance is 0.05. So for this, the critical value is 1.660. So you alpha for part B is 0.05. Dennis is giving the link. There are numerous online calculators. You just feed in the values, you get know the calculation, T values or G values. All right. Is that okay? Yeah. All right. Guys, I think you need to you you need to stay probably additional 15 minutes or so. I can't complete the remaining questions in by 10. So, but definitely by 10, 15, 10, 20, I can complete. So please be prepared to stay for additional 10 minutes, 15 minutes or so. All right. So this is about the problem where the sample standard deviation is not known. Population standard deviation is not known. So therefore, we are adopting the T statistic. Okay, I skipped. Okay, the next question will be on binomial and Poisson distributions. So the discrete probability distributions. So here there will be some calculations you need to do. Now, let us say for a binomial probability distribution, the sample size is given as 10 and the probability is given as 0.50. So then you're asked to calculate what is the probability of X being 8. Then for the same binomial probability, so you're dealing with binomial probability. So you're asked to calculate the mean and standard deviation of the random variable X. So for a binomial distribution, given n is equal to 5 and the